Yeah, there's a little. Hang on. Wait. I'm using my key. There. Ready? One, two. Am I just missing? Oh no, I got everybody. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, got everybody. Alright, what page now? Okay. Now, I haven't really been checking the homework lately because I know you have assignments to do and math assignments and stuff. But next week I'm going to start checking people's homework again. Just because you don't have a math assignment now, you know, and your exam is not too far away. So I just want to make sure people are still working as they should be. Okay, page 76. Oh, goodness. Need a new table or something. There. Right. What we're going to look at in this lesson, as you can see, is word-based problems. So we're going to look at practical problems for, I know. Practical problems for calculus. So I'll do some examples here and I'll make up some examples. So let's do this one for example. Hey guys, come on. Come on, please. What's wrong? What do you need? No? So, in this example here, what happens is a ball is thrown up in the air, goes up, and then it falls back down. And I tell you that the formula for the height, h, at time t, would be something like, use this one, 50t minus 5t squared. So you can see if t is 0, what's the height? 0. Of course, because it starts on the ground. Then it increases, and then the height decreases. Okay? So what we want to know is what is the maximum height? Well, if you think about the last lesson, the way to find a maximum is to make the derivative equal to 0. So here we have 50 minus 10t equals 0. So what does t equal? It will be 5. But I'm not finished. That's not what I want. That's the time when it's at a maximum. But I want the maximum. So what do I do? Sub it into this. So the maximum height would be 50 times 5 minus 5 times 5 squared. 250 minus 125. So that's 125. And I didn't tell you the units, but we use meters and we use seconds for time. Is in seconds. So the answer would be 125 meters. Now that's not quite finished. I still need to show that it is a maximum. So how can I show it is a maximum? Second derivative. So what's the second derivative here? So what's the derivative of this? This is the first derivative. Minus 10, which is negative, which makes it therefore maximum. So you've shown that this is the maximum height. So something like this is short, not too long. So this might be a section A question. It's not too long to do. Let's look at something a little bit more difficult. Okay. We can go down? Yep. Okay. Right, so let's take as our next example this cup of coffee. How much does it hold? How much coffee do you think is in here? 250 milliliters maybe? What do you think? Less? 200? No. 200? I think 250. So let's imagine you want to make a coffee cup and you want to know what's the best shape. The cheapest shape, I should say. So you might think, well, maybe my coffee cup should be tall and thin, or maybe it should be short, or maybe it should be somewhere in between.
We studied this today, economics of stuff. Low dimension.
Possibly, and there's actually an economics question I want to do with marginal revenue and marginal cost later as well. So yes, there are some economics examples for sure. So when you're making your coffee cup, there's two things you need. So the first thing you need is to be as cheap as possible. So you want it to be cheap. And the second thing you need when you're making your coffee cup is what? What do you think? What are the two conditions? What two things do we want? So of course we want it to be cheap. We don't want expensive paper cups.
Maximum amount of coffee?
Well, maybe not maximum, because you can make the cup as big as you want. So maybe not maximum, but what? Not minimum. So simply, when you make your coffee cup, you only expect two things. It's cheap and that it can hold a cup of coffee. I think that's reasonable. So how much is a cup of coffee? Maybe about 250 milliliters. So you want the volume to be 250 milliliters, centimeters cubed. These are the only two things I want from my coffee cup. That it's cheap and that it holds a cup of coffee. I think we think these are reasonable things, yes? Okay, so let's look at the first part, the cheap part. So I know this coffee cup is not a perfect cylinder, but we'll say it's a cylinder. So we have radius and we have a height. So what is the thing I want to be minimum? How can I make this cup cheap to make? What do you think? Yeah? Say again? Yeah, what's minimum? What exactly is minimum?
Height?
Not height. We want something to be minimum. Do we want the volume to be minimum?
Yeah.
No. No, definitely not. We want the volume to be this. So it's not the volume. So then what? Now just think about how I make the cup.
You can just use one, in the...
That's it. The material, the area. So when I'm making this cup, I have to use paper. More paper means more expensive. So it's the paper, it's the area. Because you imagine that you get the paper and then you cut the paper and you make the cup. More paper means more expensive. What's wrong, Tony? Yeah? You get the idea? Yeah. So, as you said, it's the area you want to make a minimum. The area. So you imagine that you open the cup and you get this shape. Yeah? Okay, so this here is R, and this here is R, and this here H. And what about this?
2
Oh, very good. 2 pi R. So the area is pi R squared plus pi R squared plus 2 pi R H. So the area is 2 pi R squared plus 2 pi R H. Yeah? Yeah? Question? Ask me, no problem.
That's the cup. Why you need it to
Well, because I have to make the lid as well.
different?
I know it's different, so it's only roughly approximate. You're right. Maybe the top here cost more money than the paper.
Yeah.
Yeah. But this is our first example, so we'll make it simpler, okay? So we pretend the cost is the same for both, okay? But you're right, this is probably more expensive than this. Maybe. Or maybe not. Maybe this is more expensive than this. I don't know. Okay. So I want to make this a minimum. So what should I do next?
Take the edge off.
Yeah, well, how do I find the minimum? Like, what am I trying to do to make it minimum? How do I make it minimum? Derivative equals, equals 0. So it's dA, d. Now, this is the problem. Because you have two variables. You have the or and you have the h. And this is a problem. You can't have two. You can only have one, like y and x. A and blank, so only one. So we need to replace one of them. Which one do you think would be easier to replace? The H or the O? The H, yeah, because, well, there's only one of it. But how can I replace it? Not
that's the
250?
volume.
That's it, yeah.
Volume.
If we go back to the start, we know the volume. And the formula for the volume is pi r squared H should equal 250. So H equals 250 over pi r squared. Okay, I'll just give you a minute to catch up. So if you need to write this part down, and then we can go back down. Can I go down? Yeah. Right, so it's 250 over pi r squared. Area is 2 pi r squared plus 2 pi r 250 over pi r squared. That's what I said, wasn't it? Yeah. So now we get the area is 2 pi r squared plus this will cancel this, and this will cancel this. So that's 500 over r, or I think I'll write it as 2 pi r squared plus 500 r minus 1. Okay, so write that down. Okay, continue. So now we can calculate the derivative. The A, the R equals 4 pi R minus 500 R minus 2, and also, might as well do it at the same time, the second derivative will be 4 pi plus 1000 R minus 3. Yeah, that's it. Okay, so we want this to equal 0. 4 pi R minus 500 over R squared equals 0. 4 pi R equals 500 over R squared. R cubed equals 500 over 4 pi. So R is the cube root of this number. So the radius is 3.41 centimeters. Now we need to check that that's a maximum. So when I put that in here, I know it's going to be positive because this is a positive. And if the R is positive, then what will this be? Well, it has to be positive. So positive plus positive. So I don't even need to type it in on my calculator. I definitely know this is going to be positive, which makes it a minimum. Now I'm not quite finished. What do I still need to find? What do I not know? I don't know the height. So do you remember the height equals, what did we say earlier? 2 pi r squared? 250 over pi r squared, was it? Okay, so 250 over pi r squared, and I get the height is 6.83 centimeters. So my cup, the height is 6.83 centimeters, and the radius is 3.41 centimeters. This will be the cheapest cup that can hold a cup of coffee. Give me that ruler and see how close we were. So, the radius of my cup is 3.6. Not too bad. And the height is, I think it's 9.4. So it's too short. Now the reason is...
No, like the radians in the bottom is different from the...
Yeah, that's like the one problem is you can see the bottom is smaller than the top. So this means the height will need to be bigger. And the reason they do this is to make it easier to hold. Because if it was straight and you hold your coffee, it'll go like this. So it needs to be at a bit of an angle. So this is why the answer here is bigger than this. And also maybe the price to make the lid is not the same as to make the paper, so this will change it a little bit. And also we estimated 250. Maybe it's like 275 or 280 or something like this. So I think 250 is maybe a little too small. Okay, because a can of Coke is 330, you know, and it's about the same size as a Coke. So 250 might be a little small. I think 250 is maybe more like the smaller white cups, you know. I think so. So you can see this is using the derivative in kind of like economics, manufacturing. So in a moment I'm going to do an important economics example, which is number 4 here in the book. Okay, so again, we're back to coffee in number 4. So in number 4, you know in economics what happens if you decrease the price. What happens to the demand? It should increase. Usually it increases. So if you're selling coffee and you lower the price, maybe you get more customers. Okay. So what I say in this story here is, when the price of a cup of coffee is €2, then per day. By the way, this is all per day. Let me just write that up at the top. Per day. The demand is 100 cups. And then when you change the price to €1, the demand increases to 150 customers per day. So this is the problem. If you make the coffee cheaper, you get more customers. But if the coffee is cheaper, then you make less money. So if you drop the price, is it enough to make more money from having the extra customers? You know what I mean? Like here, what happens to your profit here? It decreases. But what happens to the customers here? It increases. So it's like a balance. What is the best price for the best money? If you drop the price too much, then you make a loss, even though you have many customers. If you make the price too big, you don't make much money because you have too few customers. So there's some kind of balance in the middle that we want to get. Okay, so we start off with some information. Do you know this vocabulary? Fixed cost, FC. You know this. So the fixed cost for a cup of coffee is 70 cents. The fixed cost. That's for the shop. Yeah, the fixed cost of the coffee shop is €70. So why might the coffee shop have a fixed cost of €70 per day? Like electricity, rent, employees, insurance. So even if they sell no coffee and do no business, they still must pay €70. Now, when they make the coffee, they have something called a variable cost. So this is the actual cost to make one cup of coffee, and we'll say that is 33 cents. Okay, so this is all our information. Let's start the question. Now, I know in economics, what do you put here?
Quantity.
You put quantity and price. That's the demand curve, isn't it? Or what's it called? Demand curve, isn't it? Or supply demand? What's the name of this graph? Supply demand. We use in maths the opposite P and Q, and it's called the inverse supply demand. Now the reason for that is because it's better to picture it this way, because the shop is changing the price, and as they change the price, they can see the change in the quantity. So for this question, we put price on the X. I know in economics you put the P price on the Y. Okay. So let's plot this first. The first point is 2 and 100. 2 and 100. And then the second is 1 and 150. So what's happening? No surprise. More expensive, less customers.
So are you asking about what's the maximum profit, or?
Yes, we'll get to that. We're doing it in parts. So ultimately we're going to get the maximum profit.
Or ask about what's the best price?
Yes, the best price for maximum profit. In other words, how much should the coffee cup be to charge the customers? So the first thing we need to do is find the equation of this line. Y equals mx plus c. But it's not y, it's q. And it's not x, it's p. Okay, so firstly, let's get the m. M equals 100 minus 150 over 2 minus 1, which equals minus 50. So we have Q equals minus 50p plus C. And then what I'll do is I'll take this point and put it in to get the C. So 100 equals minus 100 plus C. Is that right? Yeah, C equals 200 then. So we have Q equals minus 50p plus 200. So this is the first part in the process. This is part A, is to make this equation. So if the coffee shop gives the coffee away for free, if they charge 0 for the coffee, how many people will come to the shop? 200, because you make the P 0. But this is a bad business strategy to charge 0 for coffee. What happens if they charge €4 for coffee? Yeah, you get 0. So this means the coffee is now too expensive. €4, nobody will pay. So the answer is going to be somewhere between 0 and €4. We know this so far. Okay, can I go to the next part of this, or do you need a minute? I think you need a minute, yeah? Continue?
Yeah.
Yep, okay. Right, so now we need to work out the total cost. So what is the formula for total cost in business and economics? It's fixed cost plus variable cost. What's the fixed cost here? €70. And what's the variable cost? 0.33 per unit, so we need to multiply this by quantity. So this is the total cost. But in the question I say, what is the total cost in terms of P? Here is in terms of Q. So how can I make this in terms of P? Well, I can use this, can't I? This gives me my Q. So if I just put this in here for P, I get total cost is 70 plus 0.33 minus 50p plus 200. So I get 70 minus 16.5p plus 66. Is that right? Yeah. So total cost is 136 minus 16.5p. P for price. Okay, so we're okay with that. Yeah. Okay, part C is I want the total revenue. What's the formula for the total revenue? The money I got from the customers. No, give me another one. Another formula, not that one. Total revenue.
Quantity.
Price multiply quantity. Oh, that's for profit. Yeah, I just want revenue. Total sales. Sorry. Sorry, do you say revenue or sales in business?
Sales revenue.
Sales revenue, okay. Total sales revenue then, PQ. Okay, again, I don't want the Q here, so I'll do a replacement. I'll replace the Q again. So I get total revenue is P times minus 50p plus 200. So total revenue is minus 50p squared plus 200p. So if the shop gives the coffee away for free, the price is 0. How much money do they get? 0, because the p's are 0. So that makes sense. Okay, so now we're getting to the interesting part. So the shop doesn't care about how much money it gets in. The shop doesn't care about their costs. What they care about is their profit, how much money they get after the costs and sales. So what is the formula for profit? Sales revenue minus total cost. So the profit is total revenue minus 50p squared plus 200p minus total cost, which is 136 plus 16.5p. So the profit equals minus 50p squared plus 16.5p minus 136. No, minus.
200p.
Oh yeah, sorry. 216.5p minus 136. Yes? That's right, isn't it? Yeah. When the price is 0, what's their profit? Yeah, they make a loss of 136. Okay. So if you think about this graph now, here you have their price, and here you have the profit. The shape of the graph will be, something like this. So if the price is too small, they're making a loss. What do you think this point is called? Do you know the name of this point in business? Break even, because now there's no profit here. And here is also the other break even. You want to be here. You want this price, because this price makes the most profit for you. So we get the derivative. Derivative of profit Oh, and by the way, we know it's a maximum because what's the second derivative here? Well, I'll write it down in a second. First derivative is minus 100p plus 216.5 equals 0.
You don't need second derivative because it's minus.
I know, yeah, but we'll just to be formal about it. What's the second derivative here? Derivative again? What do I get? Minus 100, which is negative, which makes it a max. Right, so what is the best price? 216.5 over 100. So the price is 2.165. Well, we can't charge someone half a cent. So we'll just make it 2.16. Although if you want to make it 2.17, that's fine. It's going to be roughly the same answer anyways. So what exactly does this answer mean? It means 216 is the best price. If you charge people more than 216, what happens to your profit? It actually decreases, even though the price has gone up. And if you charge people less than 216, also decreases. So this is the best price to charge people, 216.
Because there are two factors, like the price and
yes, you see, because it's a complicated relationship. So the best price is 216. So now what we can do is we can work out what the profit is if we charge 216. So where is my formula gone for profit? There it is there. Right, so let's calculate the profit the shop will make per day. Squared plus 216.5 times 216 minus 136. So I got a profit of €98.36. If I change this to 217, I wonder if it'll be about the same, or it'll be a different enough. It's exactly the same answer for 217. So 98.36 is the maximum profit. The shop cannot make more money than this per day unless they reduce their fixed costs or if they reduce their variable costs, but they can't make more than 98.36 a day. This is their maximum profit. Okay. So I know you don't do this type of maths in economics.
This is econometrics? Or
Yes, this is well, it's more just really microeconomics. If you study, who wants to study economics at university? If you're going to study economics at university, this is what you'll do in your microeconomic classes. I know because I help university students at home sometimes with maths for economics. So in first year, these are the types of problems you'll get in your economics first year exam. So you're using calculus to solve economics problems. Okay. This question is quite long, so this would be a section B question in the exam. Yeah. Because it has many, many parts to it. And in fact, there was a question like this in section B maybe 3 years ago. Okay, so I think 3 years ago they gave a question like this with DVDs or something like this. The best price for the DVD. Yeah. Okay, and make sure you have this taken down. It's an important example for maths and economics. Okay, I'll let you try these for a few minutes. And I do need you to do all of them because it's important for the exam, and there's lots of English here, so you need to practice your English and your maths as well. We did question number 4, so you need to do 1, 2, 3, 5, 6, 7, 8, 9. I know, life is difficult. Life is difficult. Okay, I'll let you try these for about, I don't know, 5 or 10 minutes, and then we'll do the next lesson. Okay. Yeah. Everything except 4. By the way, most of these are, these are really like exam questions, you know. This is what, if you get this in the exam, this is what it will look like. So it is important to practice them all, okay? So anyway, start those now for a few minutes.